Hello everyone, let's take a look at another problem. Which of the following is true of the behavior of f of x is equal to x cubed plus 8 divided by x squared minus 4 as x approaches 2? The limit is 0, the limit is 1, the limit is 4. The graph of the function has a vertical asymptote at 2, or the function has unequal finite left and right hand limits. Okay, instantly the first thing I think here when I see this function is that we have cubes on top. We have x cubed plus 8. That can be factored as a sum of cubes. And in the denominator, we have x squared minus 4, which can be factored as the difference of squares. So that's the first thing I'm going to do. And I would expect to see some kind of cancellation in the numerator and denominator. The hard part about this, for me at least, is going to be remembering exactly what the sum of cubes factorization is. But we should be able to just deduce that. And so another thing, actually, before we do anything, is we see that by substituting x equals 2 in the numerator and denominator, we do not get a 0 over 0 form. We get something positive divided by 0. And so this can't possibly have a finite limit. Meaning we'll have a vertical asymptote, and they won't be finite. I don't know if the sign as you approach from the left and the right, it'll go to either an infinity or negative infinity, or possibly only one of those. We'll go. Yeah, as we approach from the right, I suppose it'll go to positive infinity, and as we approach the left from the left, negative infinity. Let me write this function out. What I think I'll do, though, is I'll still go through with what my first instinct was and try and factor this. But you can see, substituting x equals 2, this is something finite, and that's 0. And so we can't end up with a finite limit. But let me just try the factorization, and maybe it'll be a little bit more clear what's going on. So I factored the numerator and denominator here, almost made some stupid mistakes, but that's kind of the theme of my channel. Let's do this cancellation. We're not concerned with x being anywhere close to negative 2. We're only concerned when x is close to 2, but not equal to 2. I mean, I don't know if there's an easy way to say. This doesn't even look like an easier version of what's going on. I mean, if I were writing this test for real, I would have instantly, once I realized that it's not a 0 over 0 form, I would have instantly said option D. And it doesn't distinguish whether the two infinite limits on both sides have to be the same sign or different. This is the only option we're given that has to do with the function blowing up. Yeah, there's really not much more to do on this one. I almost, stumbled down a rabbit hole of trying to factor this thing and probably trying to use some other kind of limit techniques and stuff, but it's a little tricky, I suppose, the way it's written, because it looks like they want you to exercise a whole bunch of limit evaluation techniques for things of the form 0 over 0, but it's not a 0 over 0 form. If we were taking a limit as x approaches negative 2, things would be a different story, because that is a 0 over 0. And in fact, if I wanted to evaluate the limit as x approaches negative 2, I could just substitute into here at this point, right? Anyway, if I have more to say about this one, I'll put it down in the description. Otherwise, thanks for watching.